Good evening, my YouTube viewers. It's Crystal here, and I want to do another code review for you. In this particular code review, we're going to do it on sklearn's toy dataset, the wine dataset, and we're going to see what kind of clustering comes up with that. So the first thing we're going to do is we're going to create our program, and we're going to create it in Google Colab, which is a free online Jupyter notebook hosted by Google. And I like Google Colab a lot. It doesn't do everything because it doesn't do animations, but it does take care of a lot of data science tasks that I like. So if you want to do animations, I think Google Colab is not the program for you, but you might be able to do it on Replit. One of the bad things about Google Colab is it does not have an undo function, so you have to be careful not to overwrite or delete valuable code because it could be lost forever. There is one thing you can do to get it back. You can go into the saved history, and if you go into save history, there's a possibility you can get the code back that way. So, and after we've created our program in Google Colab, what we're going to do is we're going to import our libraries. So we're going to import Numpy as NP, which is a numerical computation library, and it creates Numpy arrays. We're going to create pandas as PD, which carries out data processing and creates data frames. We're going to import sklearn, which carries out machine learning operations. We're going to import matplotlib.pyplot_splt, which is the graphics library that plots the data points onto a graph. And then we're going to import sklearn as SNS, which is a graphics library written on top of matplotlib that also performs statistical analysis on the graphics that it produces. So after we have imported our libraries, what we're going to do is we're going to read the data set. So from sklearn.datasets, import load wine, wine equals load wine brackets, data equals wine.data, target equals wine.target, and then what we're going to do is we're going to create a data frame using pandas. So data equals pd.dataframe data target equals target, and then you're going to look at data. So you've got 13 columns of data plus your target. So we look at the shape. It's 178 rows by 14 columns, and the size is 2492, which is 178 times 14. And then we're going to look at the columns. So it's got 13 columns plus your target. We're going to check to see if there are any null values. There are no null values in the data set. And then we're going to analyze the target. So you've got 0, 1, and 2. So 2 has the least amount of examples. 1 has the most amount of examples. And then 0 is in between 1 and 2. We're going to create a heat map so you can see how the different columns of data correlate to each other. And nothing has a very strong correlation, but just to make sure, I'm going to insert code to reduce columns that have a high correlation, and it didn't reduce any of the columns, so that means that none of the columns had a really high correlation. Now what we're going to do is we're going to create our train and our validation sets. So train equals data.sample brackets frac equals 0.9 comma random state equals 42 brackets. So what that does is that shuffles the data frame, and then it takes 90% of the data frame as the train. And then val equals data.draw brackets train.index bracket, and So what happens is, I'm sorry, my boyfriend's in the other room making noises and he's distracted me. So what happens is val is going to be the shuffled data set, or val is just going to be data, but then it's going to drop all of the rows of the train.index. So you're only going to have the remainder of the examples in the val data frame. So xtrain equals train.ifoc brackets colon, comma, colon, -1 brackets. What that is xtrain is going to get train and all of the columns except the last one. And ytrain equals train.iloc square brackets colon, comma, -1 square brackets. And so what that means is ytrain is going to be the last column of the train data set. And then the val set is made exactly the same way as the train data set. So, and then we're going to check the shape of xtrain, ytrain, xval, yval, and so xtrain is 160 rows by 13 columns. Ytrain is just 160 rows. Xval is 18 rows by 13 columns. And yval is 18 rows. And now what we're going to do is we're going to select our model. So there's not much point me going over k-means because k-means doesn't look very well. And none of the models look very well. They don't have a very high prediction. So we're going to go all the way to the very end. To Gaussian mixture. So from sklearn.mixture, import Gaussian mixture. GM equals Gaussian mixture, brackets, n components equals 3, comma, random state equals 42, dot fit xtrain. So you're going to fit xtrain into the model. Predictions equals gm.predict xtrain. So we're going to predict on xtrain, so you can see all the predictions right there. The length of xtrain is 160, and the length of predictions is 160, and the type of array that predictions is a Numpy array. And then what we're going to do is we're going to take unique counts equals np.unique brackets predictions, comma, return counts equals true. So what that does is that takes the unique and the counts, and it feeds it into the Numpy unique command, and the unique is the predictions, and return counts is true, and you're going to put that into a dictionary, and you're going to zip the unique counts up. So 0 is 54, 1 is 44, 2 is 62. And now we're going to check the accuracy of the predictions against ytrain, and you have 75.6% accuracy. And then we're going to check the do a graph on it, so you can see that there's 3 colors, and it's not clustered very well, is it? But you've got the 3 colors indicate the 3 digits. And then we did another graph, and that's not a very good graph. This graph is the best graph. But that was the best accuracy that I could get using the wine data set, but I wanted to show it to you. So what that means is whenever you are going to be doing any clustering, what you have to do is you have to find as many clustering algorithms as you can, and you need to fit your data into as many clustering algorithms as you can, and then select the clustering algorithm that gives you the score. Well, 75% is not a great score, but that was the best score. So that's the score that we have to use. But I just wanted to show that to you anyway. If I find some more clustering data sets, then certainly I will use the clustering data sets. But I don't do a lot of clustering because I hang out on the Kaggle website a lot. And on Kaggle, they've only had one clustering competition question. And so, because they've only had one clustering competition question, it's hard to become proficient in clustering, but I'm trying to become proficient in clustering, which is why I'm doing these code reviews. I made these videos and I made these blog posts. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching my video, and I look forward to making more videos for you in the future.